Hello children, welcome back to my channel. I am now dealing with quadrilaterals of ninth class, parallelogram and their properties. In that theorem 8.1, the diagonal of a parallelogram divided into two congruent triangles. This is a theorem. So let me consider A, B, C, D is a parallelogram and AC is the diagonal. So now let me talk about this. S is the diagonal. So what is given to us? You have got ABCD is a parallelogram. AC is the diagonal. Now what you require to prove? You need to prove that triangle ABC is congruent to triangle ADC. The statement says the diagonal of a parallelogram. This is the diagonal. The diagonal of a parallelogram divides it into two congruent triangles. So triangle ABC is congruent to triangle ADC. You have to prove. So what is the proof? Let us see. The proof here is in triangle ABC and triangle ADC, in these two. Now let me call this as angle 1 and this as angle 2, angle 3, angle 4. This is easy for you to learn, children. See, in these triangles, angle 1 is equal to angle 4 because they are alternate angles. See, these two are parallel lines and this is a transversal. So, these two are alternate angles. Similarly, angle 2 is equal to angle 3 because they are also alternate angles. How are they alternate angles? See, this is a transversal, these two lines are parallel, so these two are alternate angles. And AC is equal to AC common. It is common for both the triangles. Therefore, triangle ABC is congruent to triangle ADC basing on angle, side, angle property. So, you have proved the statement, children. So, once again, what is given? The diagonal of a parallelogram, divide it into two congruent triangles. So, this is a parallelogram. AC is the diagonal. What we require to prove? Triangle ABC is congruent to triangle ADC. Now, in triangle ABC and in triangle ADC, I have divided this angle as angle 1, angle 2, angle 3, angle 4. This way, if you do, it is very easy for your children. Instead of writing angle CAB, angle 1 is easier for you. Instead of writing angle ACD, angle 4, writing of angle 4 is easy. That is why I have written like this, children. Angle 1 and angle 4 are alternate angles for this AB is it. AB is parallel to CD and AC is transversal. So these two are alternate angles. So they are equal. Similarly, for these two, AD and BC, angle 2 is equal to angle 3, they are alternate angles. And also AC is equal to AC common. So triangle ABC is congruent to triangle ADC. This is the proof for this theorem, children. Please note it down. So the next theorem, children, in a parallelogram, opposite sides are equal and opposite angles are equal. So this is parallelogram ABCD. So what is given to us? ABCD is a parallelogram. That's all. What is RTP? We need to prove that AB is equal to CD and AD is equal to BC. Angle A is equal to angle C. Angle B is equal to angle D. This we need to prove. Here we have a construction, children. What is the construction? You have to join A and C. Join AC. Now, let me talk about proof. Now, this AC, divide it into angle 1, angle 2, angle 3, angle 4. Now, in triangle ABC and triangle ADC, in these two triangles, this proof is same as that of the previous one. Angle 2 is equal to angle 3. They are alternate angles, and angle 1 is equal to angle 4. Angle 1 is equal to angle 4. They are also alternate angles, and AC is equal to AC common. Therefore, triangle ABC is congruent to triangle ADC basing on angle side angle property. When these two triangles are congruent, then we can say that AB is equal to CD and AD is equal to BC. So, one proof we have proved, children. That is the first proof we have proved. Now we need to prove that alternate angles are equal. So, let us continue. Also, angle A is equal to angle 1 plus angle 2. These two, if you add, you will be getting. But what is angle 2? Angle 2 means angle 3 plus angle 1 means angle 4. The reason is angle 1 is equal to angle 4 and angle 2 is equal to angle 3. That is why in the place of angle 1 I am writing angle 4. In the place of angle 2 I am writing angle 3. But what is angle 3 plus angle 4? This is angle C. Therefore, angle A is equal to angle C. So, we can say that similarly, see, I have proved angle A is equal to angle C. In the same way, we can prove that I'll write similarly, we can prove that angle B is equal to angle D. Therefore, in parallelogram, therefore opposite I can write directly, opposite sides are equal, opposite angles are equal. Hence, proved. We have proved it in this way, children. So, once again, I'll explain you about it. See, in a parallelogram, opposite sides are equal and opposite angles are equal. This is a property. See, we are talking about parallelogram and their property. This is one of the property. First property in theorem 1, we said that the diagonal divides the parallelogram into two congruent triangles. Now, second property is the opposite sides of parallelogram are equal as well as the opposite angles are equal. This we are going to prove here. See, ABCD is a parallelogram, that only that they have given. So what is RTP? We need to prove that AB is equal to CD, AD is equal to BC, angle A is equal to angle C, angle B is equal to angle D. That is, opposite sides are equal and opposite angles are equal. These are the things which we need to prove. Here the construction is you have to join AC, then we are getting two triangles, just like what we have done in the theorem 1, 8.1. Same way, alternate angles. I have given names 1, 2, 3, 4 here, children. Angle 2 is equal to angle 3, alternate angles. Angle 1 is equal to angle 4, they are also alternate angles. And AC is equal to AC common. So these two triangles are congruent basing on angle side angle property. After these two are congruent, when two triangles are congruent, their opposite sides are equal. So AB is equal to CD, and their concerned sides, corresponding sides, we will say, corresponding sides are equal. AB is equal to CD and AD is equal to BC. That we have proved here. Now we need to prove that even angles are equal. So I have taken angle A. Angle A means what? Angle 1 plus angle 2. If I add, I am getting angle A. That means in the place of angle 1, I wrote angle 4 because angle 1 is equal to angle 4. In the place of angle 2, I wrote angle 3 because angle 1 is equal to angle 4, angle 2 is equal to angle 3. What is angle 4 plus angle 3? That is angle C. So I have proved that angle A is equal to angle C. So same way, if you draw another diagonal, same procedure if you do, you can say that angle B is equal to angle D. We need not do it once again, just we can write. Similarly, we can prove that angle B is equal to angle D. So opposite sides are equal, opposite angles are equal. This we have proved, children. Please note it down. 8.2 theorem. Now 8.3 theorem, children. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. So now ABCD is considered as quadrilateral. What is given to us? They have given that ABCD is a quadrilateral. They said that if quadrilateral. What did they say? If each pair of opposite sides of a quadrilateral is equal, each pair is equal. So in this ABCD quadrilateral, they have given AB is equal to CD and AD is equal to BC. Now, what we said, we need to prove what is RTP. We have to prove that ABCD is a parallelogram. This I need to prove. Now here there is a construction. Construction is join AC. I need to join AC. So if I join AC, now let us see the proof. We have got two triangles. In triangle ABC and triangle ADC. In triangle ABC and in triangle ADC, AB is equal to CD given to us. They have given AB is equal to CD. And also AD is equal to BC. This is also given to us. And apart from this, AC is equal to AC common. Therefore, triangle ABC is congruent to triangle ADC basing on side property. All the three sides are equal. So, basing on that, they are congruent. So, let me once again take this angles, angle 1, angle 2, angle 3, angle 4. So, when two triangles are congruent, their corresponding sides are equal, corresponding angles are equal, we can say. So, in that case, what you can say, angle 2 is equal to angle 3. Angle 2 is equal to angle 3. These are corresponding angles of these two triangles, as well as angle 1 is equal to angle 4. They are also corresponding angles. Therefore, what you can say, they are, no need to write, therefore, they are alternate angles. They are alternate angles. Therefore, what you can say, when angle 2 is equal to angle 3, AB is parallel to CD. When angle 1 is equal to angle 4, AD is parallel to BC. AD is parallel to BC. So here, what did you get? You have got that opposite sides are equal. Opposite sides are parallel. When opposite sides are parallel, we can say that ABCD is a parallelogram. So this is the proof of this theorem, children. Once again, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. That means in ABCD, given ABCD is a quadrilateral, AB is equal to CD, AD is equal to BC, they have given. We need to prove ABCD is a parallelogram. For this construction is you have to join AC. After joining AC, we are getting two triangles. In triangle ABC and in triangle ADC, AB is equal to CD, that is given to us, and AD is equal to BC, that is also given to us. AC is equal to AC is common. So two triangles are congruent basing on side property. When two triangles are congruent, their corresponding angles are equal. So angle 2 is equal to angle 3 as well as angle 1 is equal to angle 4. When angle 2 is equal to angle 3, these are alternate angles. When alternate angles are equal, opposite, these two sides are parallel. Similarly, angle 1 is equal to angle 4, they are also alternate angles, therefore AD is equal to, therefore AD is parallel to BC. So what are we getting with this? Opposite sides are parallel. When the pairs of opposite sides are parallel, then definitely it is a parallelogram. This is how we are proving this, children. Please note it down. 8.3 theorem. Now the next theorem, the next theorem, children, 8.4, that is, in a quadrilateral, if each pair of opposite angles are equal. So there is a quadrilateral A, B, C, D. If each pair of opposite angles are equal, then we need to prove that uh, this is a parallelogram. So what is given to us? We have got ABCD is a quadrilateral and angle A is equal to angle C, angle B is equal to angle D. Now what is RTP? We need to prove that ABCD is a parallelogram. Now let us start with the proof. We know that ABCD is a quadrilateral. Therefore, angle A plus angle B plus angle C plus angle D is 360 degrees. We know that sum of all the angles of a quadrilateral is 360 degrees. That means angle A plus angle B plus in the place of angle C, I am writing angle A plus in the place of angle D, I am writing angle B is equal to 360 degrees because angle A is equal to angle C, angle B is equal to angle D. This is the reason why I have written. That means 2 angle A plus 2 angle B is equal to 360 degrees. What do you mean by this? This means 2 times of angle A plus angle B is equal to 360 degrees. That means what is angle A plus angle B? 360 degrees by 2. That is 180 degrees. So angle A plus angle B is 180 degrees. So see here, children, angle A and angle B, these are interior angles on the same side of transversal for AD and BC. So I'll write they are interior angles. on the same side of transversal. This is for these two children, AD and BC. These are interior angles on the same side of transversal. Therefore, AD is parallel to BC. AD is parallel to BC. Let us take this as the first one that we have got. And for the second proof, that means here in this theorem, children, if you can prove that opposite sides are parallel, because they have already given us opposite angles are equal. So if you can prove that opposite sides are parallel, definitely it is a parallelogram. So to prove that opposite sides are equal, this is the first part which I have done, in which I have got that AD is parallel to BC. Now my duty is I should prove that CD is parallel to AB. To prove this, I need a construction. So here, for the second proof, the construction that I want here is extend CD to E. So when I extend CD to a point E, I am getting two angles here. I am taking it as 1 and angle 2. So when you are extending to E, we know that AD is parallel to BC. This we have just now proved. We have proved now, children, just now, that AD is parallel to BC. When AD is parallel to BC, angle D will be equal to angle 2. They are corresponding angles. Angle D and angle 2, see, these two are parallel lines. This is a transversal. Then these two are equal. Angle D is equal to angle 2. They are corresponding angles. So they are equal. And also angle D is equal to angle B. This is given to us. They have given now angle D is equal to angle B. They have given. We got angle D is equal to angle 2. They are corresponding angles. Angle D is equal to angle B. It is given to us. That means what? Angle B. Therefore, angle B is equal to angle 2. Angle B is equal to angle 2. What type of angles these two are? Angle B and angle 2. They are alternate angles for this lines. These two, CD and AB. Sorry. They are alternate angles. Since they are alternate angles, we can say that AB is parallel to CD. AB is parallel to CD. This is the second one. See, AD is parallel to BC. AD is parallel to BC, we have proved. AB is parallel to CD, we have proved. So from 1 and 2, opposite sides are parallel. Therefore, ABCD is a parallelogram. Hence, proved. This is the proof of this theorem, children. Once again, in a quadrilateral, if each pair of opposite angles are equal, then it is a parallelogram. So, ABCD is a quadrilateral. Angle A is equal to angle C. Angle B is equal to angle D. They have given. Now, we need to prove that ABCD is a parallelogram. So, see, we know that in a quadrilateral, the sum of the four angles is 360 degrees. So, I have taken this property. Angle A plus angle B. In the place of angle C, I wrote angle A because angle A and angle C are equal. And in the place of angle D, I wrote angle B. So 2 times of angle A plus 2 times of angle B is 360 degrees. That means what I have got, A plus B is 180 degrees. A and angle A plus angle B are 180 degrees means this, see, these two are interior angles on the same side of transversal. When these two are interior angles on the same side of transversal, then definitely AD is parallel to BC. And now, in order to prove that AB is parallel to CD, I need a construction. The construction is I have extended DC to E. When I have extended DC to E, I have got, see, angle D and angle 2 are corresponding angles because already we have proved that BC is parallel to AD. So, angle 1 is equal to angle 2. They are corresponding angles. But angle D is equal to angle B, that is already given to us. So, angle 2 B is equal to angle 2. What type of angles these two are? These are alternate angles. Therefore, what you can say, AB is parallel to CD. So, earlier we have proved that AD is parallel to BC. Now we have proved AB is parallel to CD. So, ABCD is a parallelogram. Please copy this, children. Now, 8.2 exercise first one, children. In the adjacent figure, in this figure, ABCD is a parallelogram and ABEF is a rectangle. Show that triangle AFD is congruent to triangle BEC. So, what is given to us? ABCD is a parallelogram and ABEF is a rectangle. So, what is RTP? We need to prove that triangle AFD is congruent to triangle BEC. With this, we need to prove. So, let us see the proof. We know that in triangle AFD and triangle BEC, in these two triangles, AD is equal to BC. Why is it AD is equal to BC? They are opposite sides of parallelogram. They said no, ABCD. ABCD is a parallelogram. So AD and BC are opposite sides of the parallelogram. They are equal, we can say. And also AF is equal to BE. They are opposite sides of a rectangle. We know that in the rectangle also opposite sides are equal and angle F is equal to angle E. Angle F is equal to angle E. They are 90 degrees because in rectangle, the angles are 90 degrees. Therefore, triangle AFD is congruent to triangle BEC basing on right angle, hypotenuse, side property. This is what the proof they have asked you to prove, children. So once again, in the problem they have given ABCD is a parallelogram, ABEF is a rectangle. We need to prove that triangle AFD is congruent to triangle BEC. So this is what RTP. Now in these two triangles, triangle AFD and triangle BEC, AD is equal to BC because they are the opposite angles of the parallelogram, and AF is equal to BE. They are opposite angles of a opposite sides. AD is equal to BC, opposite sides of a parallelogram. AF is equal to BE. These are also opposite sides of a parallelogram. Angle F is equal to angle E. They are opposite. They are angles of a rectangle. Already they are 90 degrees. We know in rectangle all the four angles are 90 degrees. So this is 90 degrees. Definitely this is also will be 90 degrees. So these two triangles are congruent basing on RHS, right angle, hypotenuse, side property. So we can say that the two triangles are congruent in this way. Now the second problem, show the diagonals of the rhombus divided into four congruent triangles. So a rhombus, This is a rhombus, children. A, B, C, D, and these are the diagonals of the rhombus. So, what is given to us? They have given A, B, C, D is a rhombus, and they have given AC and BD are diagonals. So actually diagonals will intersect at a point. Let us consider this as point O. Now what is RTP? We need to prove that triangle AOD is congruent to triangle AOB is congruent to triangle BOC is congruent to triangle COD. All four triangles are congruent, that we have to prove. Now let us see the proof. First, let me take triangle AOB and triangle AOC. AOB, BOC. In this triangle, see triangle AOB and triangle BOC. In these two triangles, AO is equal to OB. Why? The diagonals bisect each other. In rhombus, diagonals bisect each other. This is the property of the rhombus. So OA is equal to OB, I can say, and OA is equal to, sorry, OC, children. OA is equal to OC because they are the diagonal. This is the diagonal and it is dividing AC diagonal into two equal halves. So AO is equal to OC and OB is equal to OB common. It is a common side for all. And angle AOB is equal to angle BOC 90 degrees. Here also, what is the reason? Because in rhombus, diagonals are perpendicular. This is the property. Actually, in rhombus, the diagonals are perpendicular bisectors. They are perpendicular to each other. They divide each other into two equal halves. So, what you can say? Triangle AOB is congruent to triangle BOC basing on here side angle side property we have to take. Side angle side property. Okay. So these two triangles are congruent. So similarly, we can prove that triangle BOC is congruent to triangle COD and triangle COD is congruent to triangle AOD and triangle AOD is congruent to triangle AOB. Therefore, we can say that triangle AOB is congruent to triangle BOC is congruent to triangle COD is congruent to triangle BOC. Hence, proved. This is the proof, children. The entire problem is dealing with the property of rhombus. What is the property of rhombus? Says the diagonals bisect each other as well as the diagonals perpendicular. That means the diagonals of the rhombus are perpendicular bisectors. Basing on this property, we are going to talk about this problem. So ABCD is a rhombus they have given. AC and BD are the diagonals they have given. What we need to prove? See, the diagonals of a rhombus divided into four congruent triangles. Four congruent triangles means AOB is congruent to BOC, one set. BOC is congruent to COD, second set. COD triangle is congruent to AOD, third set. triangle AOD is congruent to triangle AOB. That is fourth set. So 4 congruent triangles it is proving. So how will you prove? So first I have taken in triangle AOB and triangle BOC. In these two triangles, AO is equal to OC because the diagonals are bisecting in rhombus. At the same time, what else I have taken? Angle OB is equal to OB, that is common, and angle AOB is equal to angle BOC 90 degrees because the diagonals are perpendicular to each other. So basing on side angle side property, these two triangles are congruent. So the same procedure we can prove again and again, we need not do, children. Similarly, we can prove that triangle BOC is congruent to triangle COD, triangle COD is congruent to triangle AOD, and triangle AOD is congruent to triangle BOC. That is why we can say that the rhombus is in rhombus the diagonals are dividing the rhombus into 4 congruent triangles. Please write it down. Now, third problem, children. In a quadrilateral, the bisector of angle C and angle D intersect at O. Prove that angle COD is half of angle A plus angle B. So, let us first draw a quadrilateral. This is a quadrilateral A, B, C, and D. It is a quadrilateral. The bisector of angle C and angle D bisector intersect at O. You need to prove that angle COD is half of angle A plus angle B. So what is given to us? ABCD is a quadrilateral and CO bisects angle C and DO bisects angle D. Now what is RTP? We need to prove that angle COD is equal to angle half of angle COD is equal to half of angle A plus angle B. This we need to prove. So let us see the proof. See, CO is dividing it into two halves. So I am writing this as angle 1 and angle 1, this as angle 2 and angle 2. Now in triangle COD, angle COD plus angle 1 plus angle 2 is equal to 180 degrees because the sum of three angles is 180 degrees. So let us keep it as it is and let us take also angle A plus angle B plus angle C plus angle D is 360 degrees, you know. That means what? Angle A, angle C plus angle D is equal to 360 degrees minus of angle A plus angle B. I brought this angle A plus angle B this side. So angle C means what, children? Angle C means 2 times of angle 1 plus angle D means 2 times of angle 2 is equal to 360 minus of angle A plus angle B. That means 2 into angle 1 plus angle 2 is equal to 360 degrees minus angle A plus angle B. That means angle 1 plus angle 2 is 1 by 2 into 360 degrees minus angle A plus angle B. Yes or no? This 2 has come here. This means angle 1 plus angle 2 is equal to 360 by 2 minus half of angle A plus angle B. So, angle 1 plus angle 2 is equal to 180 minus half of angle A plus angle B. Now, I am taking this angle 1 and angle 2 value in this. What I have taken? Angle COD plus angle 1 plus angle 2 is 180 degrees. So that means angle COD plus, in the place of angle 1 and angle 2, I am taking 180 degrees minus half of angle A plus angle B is equal to 180 degrees. That means what? I want angle COD. Angle COD is equal to 180 degrees minus plus 180 when it goes here, minus 180 degrees minus 1 by 2 becomes plus 1 by 2 angle A plus angle B. So 180 and 180 will get cancelled. Therefore, angle COD is equal to half of angle A plus angle B. Hence, proved. This is the proof of this theorem, children, this problem, children. So once again, in a quadrilateral, the bisectors of angle C and angle D. The quadrilateral is ABCD. I have not written here, children. In a quadrilateral, ABCD. I forgot to write. In a quadrilateral, ABCD. I'll write once again, otherwise. In a quadrilateral ABCD. Problem is like this. In a quadrilateral ABCD, the bisector of angle C and angle D intersect at O. You have to prove that angle COD is half of angle A plus angle B. So this is a quadrilateral. CY is the bisector of angle C, DY is the bisector of angle D. We need to prove that angle COD is half of angle A plus angle B. This is what we need to prove. So here you see, children, first I have taken triangle COD. In triangle COD, angle COD, see, CY is bisecting, means what? It is dividing angle C into two equal halves, 1 and 1. OD is bisecting angle D. So what we can say? Angle D is angle 1 plus angle 2. So in triangle COD, angle COD plus angle 1 plus angle 2 is 180 degrees. This I have written. Now also we know that ABCD is a quadrilateral, so the sum of the angles is 180 degrees. So angle A plus angle B is equal to, the force angles sum is 360 degrees. So angle C plus angle D is 360 degrees, angle A plus angle B, when it goes there, minus of angle A plus angle B. So what is angle C? Angle C means 2 times of angle 1 plus angle D means 2 times of angle 2 is 360 minus of angle A plus angle B. That is 2 into angle 1 plus angle 2 is 360 minus angle A plus angle B. So what is angle 1 plus angle 2? Half of, means this 2 when it goes here, half of 360 degrees minus of angle A plus angle B. That means angle 2 plus angle 3 is 360 by 2 minus half of angle A plus angle B, distributive property. So angle 1 plus angle 2 is 180 degrees minus half of angle A plus angle B. So this angle 1 and angle 2 values I have substituted here. Angle COD plus angle 1 plus angle 2 is 180 degrees we have got, and angle COD plus angle 1 plus angle 2 is 180 minus half of angle A plus angle B is 180 degrees. So what is angle COD? This 180 degrees plus, when it goes there, minus 180 degrees minus half of angle A plus B becomes plus half of angle A plus B. 180 will get cancelled. So angle COD is half of angle A plus angle B. This is the proof of this problem, children. Note it down. Now with this, I am going to conclude my part today. In the next class, I will be doing the next one.